Well, hello everyone. This is my. I've done this talk a couple of times. I try to change it each time I go somewhere new. So I have a demo at the end of the day. If the god of demos is with me, it will hopefully work. Um, my name is Abdel. I'm a cloud developer advocate at Google. I've been at the company for almost 10 years. And I'm also hosting, or I co-host a podcast on Kubernetes. Don't know if there are any people. No? All right. I'll give you a minute to sign up. Um, I just want to start with disclaimer. I've been on Kubernetes for almost 5 years now, since its creation in 2000 and a little bit more than 5 years. Kubernetes came out first time in 2015. Docker came out first time in 2014. And I've been doing quite a lot of implementations, working with customers, working on various projects, all sizes. And I've seen my fair share of when things work and when things doesn't work. So this talk is not really an exhaustive list of everything security on Kubernetes. It is more like a way for you to think or to reason or to have a logical layer thinking about security when it comes into a Kubernetes installation. Kubernetes is a fairly complex system. It has a lot of layers that can be breached and therefore should be secured. And this is especially important and relevant if you are doing your own Kubernetes. But the overall lesson I want you all to take from this is that security is everybody's responsibility in a company. And security is a multi-layered approach. There are multiple layers in any system. Doesn't matter if it's based on Kubernetes or just regular server with Linux or Windows and an application inside of it, or a Windows or a box with Linux or Windows and Docker and application inside. The same lessons that we are going to learn today could be applied to anything, any installation you have. Before I move on, how many people here are using Kubernetes? By show of hands. All right, fair share of you. How many people here have never actually touched Kubernetes at all? One person. Couple people. Okay. How many of you are familiar or have heard the word software supply chain security? Okay, 2, 3 people. All right, so okay, we'll touch on that a little bit as well. Before I do that, let's start with very basic introduction. I think you have seen this before. What is a container? And the easiest way I like to describe that is I like to describe how we by we mean people of my generation in tech industry, came to the tech industry and how we saw people deploying stuff and how that have shifted very quickly on the last 10 years or so. A long time ago, and here I mean, if you're older than, if you have been in the industry for older than 25 years, you're probably screaming saying, where is mainframes? I am explicitly leaving them out, right? Because I think that if you started in the tech industry after 2000, you have no freaking idea what mainframe is. Anybody here knows what mainframes are? 2 people, right? Just my expectations. 10 people. Okay, good. So at some point we had bare metal servers. So bare metal servers, regular servers, a box, you stick an operating system inside of it, and then you deploy some stuff there. You have the hardware, you have your operating system, you install your dependencies, and then you have your code. This is back in the days when sysadmin was a thing, right? I started my career as sysadmin. It was pretty cool. Turns out I was actually doing DevOps, but I was not calling it DevOps for some reason. And when you had this, what used to happen is your application developer comes very excited with new version of the app, give it to you, hopefully not an USB stick, and they go like, hey, please deploy this. And you try to deploy it and it gives you errors. And you go like, oh, this doesn't working. And then your application developer goes, oh no, by the way, because one of my dependencies, now I am running version 2.1 plus 2. So I updated the version of my dependencies on my laptop. So you should do so. And you as a sysadmin go like, but I have an app that requires the older version. So how do I solve this, right? How can I run 2 apps requiring 2 different dependencies on the same operating system? So we somehow came up with virtualization. This was not the only reason. Dependency management was not the only reason. There was many reasons why virtualization became a thing. I believe one of them is because some companies realized they can make shit lot of money, and they did. So the idea of virtualization was, let's separate the hardware from the operating system. We create a virtual machine. Inside the virtual machine, we have the OS, the dependencies, and the application. That solved kind of some of the problems of bare metal deployments. Namely, the main one is isolation. A virtual machine is by definition a sandbox environment. two virtual machines running on the same host, physical host, cannot breach the barrier between them, depending on the kind of hypervisor, but generally speaking, they can't. And then 2014, somebody, well, the founder of Docker went on stage at PyCon, I believe, in San Jose, somewhere in the US, and showed the first version of Docker. And the idea of Docker was, we'll keep the same host, whether that's a virtual machine or a physical server, we'll keep the same OS, we just created a new way to basically package application and dependencies and configuration in something we call a container, right? And then containers became popular. They mainly become popular for, I believe, one main reason is because developers are lazy. No one wants to learn C groups and namespaces and network and chroot and all these crazy things that Linux has. Because all the stuff that Docker enabled people to do existed, or all the things that enabled Docker to exist as a tool existed in Linux for a while, right? All the underlying necessary pieces existed in the Linux kernel for a while, and then Windows caught up at some point. But no one wanted to learn this basic stuff, right? How many people here have done chroot? It's a nightmare, right? Like it's very difficult to troubleshoot. C groups, namespaces, all these things are like no one wants to read the manual of Linux basically. So what Docker really did is it created an abstraction layer that allows us to package application, its dependencies, run it as a binary. Essentially, it looks like a binary. It's not. It's a process, but it ran it as a binary without really all the hassle of understanding how it works under the hood. And obviously, what happened is 2015, Kubernetes was released, and the rest of history. It is becoming sort of the de facto way of running applications in cloud. Some people argue it's not. I'm not too much into argument. There are actually data proving that more and more people are using containers and more people are using Docker. And this kind of new model supposedly made everybody happy because then as an application developer, I can just ship the new version of my app, give it to my DevOps people. They would run it for me. They don't have to worry too much about dependencies. Dependencies are inside the app. I can scale it up and down very quickly. I can actually iterate over building containers very quickly. And the ephemeral nature of containers makes them very, very quick to start, stop, restart, etc. But this is the nightmare of every security person. One of the main reasons is because, and this is a quote I like, I forgot who said this, but there is this quote that I like that says, containers doesn't contain. If you think of containment from a pure security perspective, which is pure isolation between applications, containers in their current formats, as in Docker and what today becomes what we call OCI, the Open Container Initiative, which is the standard that every single container build tool follows to make containers, they all do the same thing, which is when your application makes a syscall, that syscall is passed directly to the OS. A syscall is system call, for those who doesn't know. It's essentially open file, close file, send stuff to the network, things like that. So the container runtime or the container process doesn't really do anything to the syscalls. It proxies them directly to the kernel. And that's how some people at some point discovered it was easy to breach a container, because if you are inside the container and you can somehow make a syscall to escalate your privileges, you can take control over the entire host, right? So to recap, containers do inherently have some security advantages. Because they are short-lived, they are easy to patch. Because they are immutable, it's very difficult actually to change a running container. Depending on where do you run your containers, they can come with some default security configurations. One of the main ones being, please do not run your containers as privileged. That's like literally everybody's nightmare. You don't want to do that. And what happened over time is that some isolation technologies started popping up that could guarantee the isolation problems I was talking about. So here I'm talking about things like gvisor, which is an open source tool, Kata containers, which runs micro VMs, which is essentially a VM running, container running inside the VM, etc., etc. Then 2015, Kubernetes came to the picture. We open sourced it, and the idea of Kubernetes was running Kubernetes containers at scale. Kubernetes was really released to solve the same problem Google had for a very long time, for almost 20 years. which is running one container or running one app is easy. Running multiple containers on the same host is relatively easy, Docker Compose. Running multiple containers across multiple hosts or multiple servers is difficult. You can't do it manually. Well, you can, but you're going to be spending a lot of time on the command line. So what Kubernetes promised to solve is taking this entire infrastructure, which could be a set of hosts or machines. I'm explicitly using the word machines or hosts here because I do not like to use the word node or VM, because from Kubernetes perspective, as far as Kubernetes is concerned, the underlying piece of infrastructure could be anything. It could be a virtual machine, it could be a physical server, it could be a Raspberry Pi, it could be a laptop, it could be anything. It doesn't really matter. So the idea is taking all these pieces of infrastructure, stitch them together, and then create one abstraction layer and give me an API. I can talk to that API and tell the API, do this or not really do this. I can tell the API, this is my intention. I explain to the API, I want to run one replica of one application, and then Kubernetes would run it for me. This, for those of you who raised their hand when I ask if you have used Kubernetes before, this might sound very familiar to you. For those of you who didn't, this is high level how the architecture of Kubernetes work. You as a user on the left use an API or command line to talk to what we call a control plane. The control plane contains a bunch of components. You are mostly or you are exclusively interacting with the API server all the time. The API server stores stuff in etcd. There is a scheduler that schedules things. There are controllers, which I'm not going to explain because that would take another hour. Then on the node side, I said I'm not going to use the term node, but I was wrong, so I have to fix that in my slides. I have basically three components: the kubelet, the kubeproxy, and the container runtime. I'm going to give you, even for those who know what Kubernetes is, I'm going to give you my easiest way to explain Kubernetes to people who know containers but doesn't know Kubernetes. When you have a container and you want to run it, you do a Docker run, right? Right? You agree with me? Right? Good. When you have a Kubernetes cluster, you tell Kubernetes to tell a node to do a Docker run on your behalf. That's the shortest way to understand what Kubernetes does. When you have a Kubernetes cluster, you don't explicitly tell the cluster what to do. You send some stuff to the API, and the API will eventually call some kubelet somewhere, which will call the container runtime, which will execute the container on your behalf. Right? That's like the easiest way to explain what Kubernetes is for somebody who just uses Docker. So security-wise, because of the nature of Kubernetes, because of all these moving components and all this like network and stuff, there is quite a lot of places where things can go wrong. Things can go wrong at the infrastructure level, right? Things can go wrong at the software supply chain level, so the application itself. How do we get the application from where we develop it to where we run it? And things can get wrong on the runtime level. The first question that people ask themselves when they want to use Kubernetes is, do we do self-manage or do we let somebody else run it for us, right? So self-manage obviously is you run it and you deploy it and you run the entire thing yourself. How many people here, those who raised their hand, how many of you are doing actually self-managed Kubernetes? One person, two, three. All right, that's interesting. We need to talk. I want to know why you're doing this. But yeah, you can do it yourself, or you can just let a cloud provider take care of that for you, right? Every single cloud provider today have some sort of managed Kubernetes, which sometimes consists of, they would manage the control plane for you, and you would manage the nodes, or they would manage the entire thing, and they would just give you access to the API server. So the examples of fully managed Kubernetes are things like AWS Fargate, or on Google Cloud, we have something called GKE Autopilot. GKE stands for Google Kubernetes Engine, and Autopilot is the fully managed version of that. So we don't let you touch the nodes. It's fairly limited in terms of what you can do with it, so it's secure by default, and we only charge you for what your pods consume. But if you're doing your own self-managed Kubernetes, the first question you should ask yourself is which operating system you should use. And obviously, the less is always better. There are quite a lot of choices. You can pretty much use any Linux container. You can also use Windows. My preferred choice for self-managed Kubernetes would be something like CoreOS or whatever CoreOS became today. I know it doesn't exist anymore, but there is like a version of it. Like there is the new version after CoreOS was sold to Red Hat. I don't remember the name. But essentially, the least amount of stuff your operating system has, the better it is, because the less code, the smaller is your attack surface potentially. Managing your access, Kubernetes comes with this idea of namespaces. You can use namespaces to isolate applications from each other. Pretty much every single concept that Kubernetes have, every single object, almost every single object is namespace bound. Whether that's RBAC, role-based access control, that's also namespace bound. Network policies are namespace bound. Quotas are namespace bound. So use this to your advantage. Do not deploy everything on the same namespace. There is a reason why namespaces exist. You can go there are really two kind of ends of the spectrum for how to use namespaces in Kubernetes. On one end is I just use everything, I deploy everything in the default namespace. That's one way to do it. The extreme end is I isolate every single namespace for every single app, and I only give applications access to the namespace they need. And that's what we call multi-tenancy. Multi-tenancy is essentially running multiple tenants. A tenant could be an application, a business unit, whatever, on its own namespace. But the TLDR here is namespaces exist for a reason, so use them. Talked about RBAC very quickly, role-based access control. There are actually a lot of tools in the open source space today, and especially in the cloud native space, Cloud Native Compute Foundation, that makes RBAC easier. I know doing RBAC manually is a nightmare, but it is the easiest, most straightforward way to isolate what or who can do what, who can list which objects in which namespace. If you are on a cloud project, or you're using any cloud provider, you probably have IAM, Identity Aware Proxy, and at least most of the cloud providers I tested, namely the three main ones, Google, Azure, and AWS, they have some nice integration between their IAM and their Kubernetes installations. So use that as well to your advantage. Now, one of the main questions I get all the time is, if my IAM can allow me to manage access on a project level / account level if you're on AWS, which typically is what IAM does, right? So how do I make IAM and RBAC play together? Well, my most straightforward answer would be use IAM to manage access at the project / account level, and then everything Kubernetes use RBAC for that, right? Kubernetes have this concept of pods. Pods are individual components that have an IP address, so you can also isolate traffic between them. Network policies is one of the easiest way to do that. You can, with network policies, you can basically say this pod can talk to this pod on these ports, essentially firewalls, but inside the cluster. My advice is go with the lock everything by default, which means drop a namespace, drop a network policy, which is the default one, which closes all communication inside the namespace and only open the network communications that you need, right? There are even some tools that can actually allow you to do cluster-wide network policies. Network policies by default in Kubernetes are namespace bound, but there are tools like Cilium, for example, which is CNI, that can allow you to deploy a cluster-wide network policy. So one of the main communication that you will need in Kubernetes installation is DNS. So if you have a namespace and you have applications inside that namespace, if you put a network policy that locks or blocks all egress and ingress traffic, one of the first problems you're going to notice is your applications will not be able to resolve DNS, right? So, and you need to resolve DNS if you want to do service discovery or to do pod-to-pod communication. So you can put a default network policy that blocks all traffic and only opens 53. The issue is that you will have to do that in every single namespace. Tools like Cilium can allow you to create a policy which applies on the entire cluster. So it gets kind of inherited into all the namespaces. Come on. I'm going to briefly touch on Istio. I know it's a very complicated topic and it will require an entire talk by itself, but Istio, or basically service mesh, is one of the also ways to implement some security features. It does three main things: securing communication. It has a lot of policies for authentication. You can do real authentication, real service authentication. It has things like MTLS, mutual TLS. So that's pretty cool. It has ways to give you like kind of observability out of the box. And it could potentially increase your operational agility. It has built-in features for traffic management, so you can do canary deployment or blue-green or stuff like that. My only warning point would be it is a very complex system. Not only Istio, any service mesh, it's really complex. It adds a lot of operational overhead. So sort of you have to balance out or kind of assess whether you are okay with taking over this additional operational overhead in exchange for all the benefits that Istio give you or not. From your application layer perspective, obviously do not run as privileged containers. We touched on that. If you want some extra additional isolation, I would recommend you to look into gvisor or kata containers. Those are my two favorites. So what gvisor does essentially, it adds a mini kernel between your application and the host. And this kernel here implements some of the syscalls that the Linux kernel typically do. This only works on Linux for today. But basically, when your application makes a call, that syscall is not interpreted by the host kernel, it's interpreted by gvisor. It's written in Rust, so it's super fast, and it guarantees a level of isolation. There is only one kind of point to keep in mind with gvisor, is that because it's a re-implementation of a lot of syscalls, not all the syscalls that the Linux kernel is able to handle are re-implemented in gvisor. Therefore, some stuff might not work. That's my warning for you. Just keep it in mind. Yeah. So let's get to the software supply chain security because I want to spend some time on this. For those of you who doesn't know what software supply chain, or you have heard this and you don't understand what it is, the term software supply chain security can be split into three different components. Software, which is application, right? That's easy to understand. Supply chain essentially means the process by which you get your application from development into production, right? So all the processes, CI/CD, testing, QA, moving between environments, all that stuff, all the things, all the places that your application have to move through to get to production, that's the supply chain. And security is security. So the whole idea of software supply chain security is let's look at this entire process of getting applications from A to B. So A being development, B being production. Look at what potentially can go wrong and how can we secure it. So this is how your typical software supply chain looks like. You have your source code, which you have written. You build it, you add some dependencies, you package it, and you run it, right? Those dependencies, 100% of, 99% of the time, they're coming from the internet. You don't know where they are. But those dependencies also have their own software supply chain security. Like the people who are building libraries that you depend on, they also use some sort of CI/CD to ship those libraries to you. What can go wrong? Well, some of the predictions. Well, I'm not gonna talk about predictions, but I can talk about some recent use cases. Log4j, everybody remembers that one? SolarWind. SolarWind was a company, software company that got hacked, and the impact was the Continental Pipeline in the US, which is a pipeline supplying the East Coast with gas and oil, was down for a few weeks, and people panicked. I'm going to talk actually about an example that not a lot of people talk about because it kind of went under the radar, or if you don't live in the Nordics like I do, you probably never heard of it, Kaseya. So in Sweden, we have it's not only in Sweden, but it is a Swedish company. We have a big supermarket chain called Coop, right? And Coop last year had to close their stores for 24 hours, like across the entire country, 500 stores, had to close them. Why? Because Coop was basically using a third-party IT company to manage their self-service checkouts and their cashiers, right? That third-party company was using a company called Kaseya, and Kaseya is an IT management software. It's an asset management software. It's a software that allows you to know which devices are deployed where and push patches to them and stuff like that. What happened is Kaseya, the company, built a new version. So they supplied a patch and then they shipped it to their customers. So in our example, the customer is not Coop. The customer is the IT company that manages, self-service checkout for Coop. So this company just took those patches and deployed them into Coop's system. And for 2 months, they just had a backdoor, and they actually managed to sniff a bunch of customer data. Things like, luckily, no credit cards, because in Sweden, the cashier cannot store credit cards, whether it's the self-checkout or the one where you have a person scanning your groceries. But things like who bought what, when, what articles, what prices, and stuff like that, all of that data was actually siphoned out. And this is a big problem because The issue with software supply chain security is that you might be as careful as you can in terms of scanning the software you build and making sure it's secure. But if you're depending on a third-party software, sometimes you would just blindly trust it. And sometimes this third-party software might actually be used in parts of your company, which you're not even aware of as a SecOps developer, CISO, CTO, whatever. Your HR software, right? Your CRM software, stuff like that. No one is building HR and CRMs anymore unless you are the company that makes those softwares. Everybody just uses third-party software. And so you are at the mercy of whatever that company does. And you probably don't know if they have been hacked. I can give you actually another example. This probably will talk to you a little bit more. Last year, do you know Circle CI? How does anybody know this company called Circle CI? Few of you? Yeah. It's a managed CI tool, right? You know what happened last year? Remember? Some of their some of their customers' AWS keys leaked. It happened over Christmas. So they were drunk and overfed, and they took 2 weeks to tell the customers, right? So yeah, you rely on a third-party software and you trust them, and they can screw up. So basically, the TLDR here is software supply chain is important. Don't trust anyone. So basically, when we look at this way we supply software to production, every step could be vulnerable. Every step could be hacked. So that started this shift left movement a few years back, maybe 2 years back. People started saying, okay, why don't we shift the security responsibility to the developers or to the development environment? Why don't we make sure that we have ways to implement software supply chain security across the entire process, but also make developers aware of what they're doing and responsible for what they're doing? So that comes through things like scanning, for example. If you have a way for you to provide your developers with visibility into the dependencies they use, maybe they are building some software, they are hosting it somewhere, hosting the artifact somewhere, and then you're automatically scanning it for them and telling them, hey, you have these vulnerabilities, you have these libraries, blah, blah. That could be one way to look at shift left. But there is also the shift left from a trust perspective. So how do I make sure that the software that I'm about to deploy to my production have been built by my developers and not by somebody else? And when I say developers, it doesn't necessarily mean the person. It could be the CI pipeline. How do I make sure that the CI pipeline that I built is the one that built this piece of artifact that I'm about to deploy to production? So a group of companies got together and formed what we call, do I have a slide about it? Sghiouar. So Sghiouar is a consortium. It's a group of companies that got together, and they started coming up with tools and also processes and ways and frameworks for implementing software supply chain. Tools like Cosign, which is a signing tool. I'm going to show a demo later. There is also ways for verifying signature, and there is ways for keeping trace of who have signed what. But they also came up with this thing called SLSA. It's written SLSA, which stands for Software Level of something. But software level of security, whatever, something. It's SLSA, you look it up. It's essentially a set of practices that they tell you if you meet those criteria in terms of how you supply your software from development to production, you are either meeting SLSA level 1, SLSA level 2, SLSA level 3, or SLSA level 4. I'm not going to go into the details, but I can give you some examples. Things like, are you attaching the SBOM, which is the software bill of material, which is essentially the list of the dependencies that makes up this image. So when I build the container image, I could also generate a software bill of material, which is a list of all the libraries, all the binaries that exist inside the image, and I attach them as metadata to the image itself, so that later on I can rebuild the image from the same set of dependencies if I need. So that's one criteria, and I think it's level 3. Or things like, is your CI pipeline attaching metadata that says how this image have been built? When was it built? Who built it? How long it took to be built? What was the build output? Was it successful? Did it fail? Etc. Etc. Stuff like that. So essentially, those are practices that if your software supply chain meets, they are compliant with one of these levels. And then they have components. There are a combination of open source command line based components like Cosign, but also online stuff. So if you use Cosign, Cosign allows you to sign container images. Anything that is OCI can be signed with the Cosign and verified. If you need the key to sign them, you can use Recore. Sorry, you can use the certificate authority. You can use whatever key you want, but they have their own certificate authority. And they have a bunch of other components. I'm not going to go into the details. I want to actually show you a demo very quickly. This is not it. This is it, right? I did a Docker build, hopefully, hoping that it will finish before I get to the demo, but apparently it didn't. Come on, something. Come on. Right. Apparently it doesn't want to work, so let's yeah, let's do something. I'm gonna just like pull a random image from the internet. So I'm just gonna pull an Nginx image, right? Nothing wrong so far. I have it, right? And I'm gonna simulate that this is my actual. It's not my app, but let's just, for the sake of simplicity, say that this is my app, right? I built this app, so I'm gonna go ahead and tag it because what I want to do is I want to deploy it. Yes, sorry. So yeah, so I'll just tag it because, you know, when I build an app, I want to be able to deploy it, so I need to push it to an artifact registry. So I'm just tagging it with that artifact registry. If you're doing Docker and using Kubernetes, I think these stuff are familiar to you. Then I will just go ahead and push it. And when I push it, I want to grab the SHA for that container image. So go ahead and do that. No, Nginx. Right. So I'm just gonna go ahead and push it to my artifact registry. Hopefully this will work. Come on. Okay. Hopefully it was pushed. Yeah, I have my image here, right? So as of now, nothing can prevent me from just doing this, right? Just kubectl deploy nginx -- image nginx. This should just work, right? So I just deployed. What? Is it create or deploy? No, create. Ah, so I'm just go ahead and delete it and deploy it again, right? And this should just work. Yes, I have a hopefully working container image at some point. Yeah, it's running. Anybody can tell me what's wrong with this? What I just did? Just shout it out. No one? Yeah, exactly. I don't know what I'm running, right? I just pulled random image from the internet and deployed it. But I also don't know, even if the image itself is hosted in my own artifacts registry, I don't know where that image is coming from, right? So if I'm a DevOps person and my developer tells me, hey, there is a container image, it's in my artifact registry, go ahead and run it. How do I know it's coming from them, right? How do I know? How can I trust that that container image I'm deploying is coming from the people who said they built it? Beside the fact that I pulled it from the internet, obviously, which you shouldn't do. So one way you could do that is you could sign it. So how can I do that? So there is this command line called cosign, which can allow you to sign a container image, right? And for signing, you need a key, basically an asymmetric key, public private key. You can use whatever. In my case, I'm going to use GCP KMS, so the key management system built into Google Cloud, but you can use any KMS from anybody. So I'm just going to go ahead and change this container image here. Right? and just run a cosine, right? So this will take the SHA of my container image and then generate a signature and push the signature or add the signature to my container image. So if I go here, refresh, I'll see that I have a new thing, and that new thing is a manifest which contains a signature, right? Now, what can I do with this signature? Well, assuming that it was me, the developer, who have signed the image, and that key is available, so it's hosted somewhere, at least the public version, the public portion of the key is hosted somewhere. Well, anybody down the line in my company can just use cosine to verify that the container image is actually mine, right? The cosine claims were validated, the signature was verified against the public key. So yeah, so anybody can basically do this verification. You can do it as part of your CI pipeline. You can do it as part of your build pipeline. It doesn't matter. If I want to go a step further, Cosine or Sghiouar, they have an admission controller for Kubernetes. So essentially a gatekeeper that can sit between the API server and you. So when you send stuff to the API server and you say, hey, deploy this, it will verify if certain conditions are valid. So I already deployed it, but I will just add a policy. And the policy basically says for all the images deployed everywhere, verify against an authority, and it's this key. It's the same exact key I used to sign the image. So I'm just going to go ahead and deploy this policy in my cluster. So the policy is there. Then the next thing I need to do, and this is just for the sake of demo, I'm creating like a random namespace called test, and then I need to label it. So I just need to add a label that says policy.sghiouar.dev include true. So I'm going to go ahead and do that. And now, if I want to go ahead and deploy like a random image into the namespace, like kubectl create deploy. Thank you. Nginx dash image nginx dash in test. So if I want to deploy like a random image into my namespace, it should fail because it would say that the signature was not verified, right? Because I tried to deploy some stuff from the internet. But if I want to go ahead and deploy the one I signed earlier, it should just work because I signed it, so it can be trusted. There you go. So yeah, this is something that you can easily implement in your CI pipeline. Cosine is free. You don't have to use Google KMS. You can use any key management tool, or you can use the one coming from Sghiouar. And this way, you have at least you can claim in your next promotion that you have done shift left. Thank you very much.